Next topic of this chapter is rectangular components of a vector. A component of a vector is effective value in a given direction as the resultant of a component vectors along the specified direction. It is usually convenient to resolve a vector into its mutual perpendicular direction component. Such components are called rectangular components. So this is the definition of rectangular components of the vector. Now we will see its explanation. Further explanation about rectangular components of the vector. Let there be a vector A represented by line OP. This is the plane shown in a rectangular system with vectors M with vector A. This is the vector A and its x axi component in x direction, AYJ component with unit vectors. OP is the line representing this vector A. Draw the projection OM of vector OP on x-axis and projection of ON of vector OP on y-axis. So this is the projection of OP on x-axis represented by this dotted line, and this is the projection of vector A on y-axis. OM being along x direction is represented as AXI and ON is represented along y direction as AYJ. According to head-to-head rule, A vector is equal to AXI plus AYJ. AXI and AYJ are the components of vector A. Since these are right angle to each other, hence they are called rectangular components of vector A. Considering the right angle triangle OMP, the magnitude of AXI or x component of a vector A is AX is equal to A cos theta, and component of that vector Y, AYJ is equal to A sin theta. This OM line represents the inclination of a vector A having a component x which is equal to AX cos theta, and AY represents its component as AY is equal to A sin theta. Now we will see how to determine a vector from its rectangular components. If the rectangular components of vector are shown in the figure 2.6, this is the figure we will again use. We can find the magnitude of a vector by Pythagoras theorem. So how to find the magnitude? This is a right angle triangle OMP. In this OMP triangle, OP is the hypotenuse, OM is the base, and PM is the perpendicular with inclination theta. So OP hypotenuse is equal to base square plus perpendicular square. Putting these values, like OP is a vector A, OM is the x-axis AX, and MP AY square, A is equal to AX square plus AY square, writing the square root of A. How to determine the direction of this vector, which magnitude is determined? To determine the direction of this vector, tan theta is equal to PM over. So this is the inclination or direction theta, which is actually tan theta is equal to base over perpendicular OM, so perpendicular over base PM divided by O, and which is actually equal to AY over AX, and theta is equal to tan inverse AY over AX. Next one is the position vector. Position vector R is a vector that describes the location of a point with respect to the region. For example, this is the vector shown as R. Position vector is a vector which describes the position of a point with respect to the region. For example, this is the point AB. If this vector is drawn in this direction with R, so this vector represents the direction of this point P with coordinates A and B with respect to region O. This is called as position vector. How to represent it? It is represented by a straight line drawing in such a way that its tail coincides with the origin. Its tail is coinciding with the origin and its head with the point A as shown in the figure. The projections of the position vector are on x and y axis are the coordinates of A and B. These projections are the coordinates of points A and B. Hence, R is equal to AI plus BJ and R is equal to A square plus B square. Already we have seen how to determine the direction of a magnitude of a vector. Let this vector is in a three-dimensional space. Position vector R of a point P into A, B and C is shown in the figure is represented by three components AI plus BJ plus C and K. K is the another vector which is in the space we have seen in our previous video. Now the magnitude of this position vector R in 3D equal to A square plus B square plus C square. So this is the magnitude of the three-dimensional vector represented by R called position vector, and this is the direction of a determined vector which is determined from rectangular components, and this is the magnitude of this vector. We have calculated the direction and magnitude of a given components of a vector, and this is all about the rectangular components of a vector, in which we discussed about mutually perpendicular components, how to represent this vector or resolve into its rectangular components. We will see how this next video, how to represent it, resolve this vector into its two mutually perpendicular components called x-axis component or h is equal to cos theta, y-axis component ay is equal to ay sin theta. Next we are seeing this one and the last position vector with how to determine the magnitude of this position vector in 2D and its location and magnitude in 3D also. That's all from this video. We'll see our next video of problem 2.1, how to solve this problem related to position vectors, how to determine the distance between two vectors. That's all from this video. Next video we will see how to resolve a vector into its rectangular components.